Hello guys, welcome to my YouTube channel. So today we're going to be doing some machine learning um, project. In this machine learning project, we're going to be training random forest. It's a classifier, so we're going to be using it practically. And so we're going to get started using Python. With time, we're going to understand how the whole process goes. So we're going to start by writing the code. We're going to be doing some actual training and testing, and then we are going to finalize. So let's get started. So first of all, we need to import os. So now the import os is for interacting with the file system between the Python and the libraries and everything. So we're importing OS. So we're going to say import CV2. Import CV2. So the CV2 is an OpenCV library that handles image processing tasks. So we're going to say import CV2. Then we're going to say it should import numpy as np. So import numpy as np, import numpy as np, and then we're now going to say from sklearn dot assemble import random forest classifier. So we're going to import our random forest classifier here. We're also going to say from sklearn, we're going to also pre-processing and we're going to import label encoder. So as I've said, the numpy is for array manipulation, and then the random forest classifier is a machine learning model for classification, and then the label encoder here, we're going to use it to encode class labels into numerical values. So each of the class label will be encoded into numerical values for the system to be able to understand. And so the next step now is we have imported the required libraries. We're going to move straight to load and pre-process our image. So the first thing we're going to do is we're going to define load and pre-process images. The folder underscore paths. So we're going to say images equals to, we're going to close that. We're going to say labels labels equals to, yes. One thing we need to be very careful is that our codes must be neatly arranged. So I'm going to do something right here, give it space here so that we will understand and follow, and then we're going to move this here, we're going to move this here. I think the spelling of this folder is wrong. I guess, yes, it is wrong. It's supposed to be OL folder underscore path. Then after that, we're going to say label encoder, label underscore encoder. We're going to say label encoder. So it's a label encoder. We're going to say for the class labels, for class IDX. I'm going to explain the code later after I've written this. Class name, we're going to say os.list dir directory. That's known as your folder path. Okay, make a mistake here. Folder underscore path, and then we're going to close the bracket. Yes, we're going to now see class path, class underscore path is equals to os dot path dot join folder underscore path. I think we stay folder underscore path then we use class underscore name and then we're going to say if os dot path dot directories into brackets class path and then we're going to say for file name in OS directory then we say class paths class underscore path and then we close the bracket and then We go to the next slide. We say you can say image path. Correct. Okay, image path os path dot join class path, class and then path. Then we say file name. Then we now say image equals to the cv2 dot image read. Then say image underscore path. So we can say image is equals to cv2 dot resize image, we say the size let me see, correct here. Okay, let me see, resize image, what should I resize it to? What should I resize it to? Where should I resize it to? What should I resize the image to? Okay, let me see, 100 by 100, 100 by 100, 100 by 100. Then close bracket, and then we see images dot append, close into images dot flatten, then we close, yeah. So we say labels dot append, then say class underscore name. Test again. What else again? So that's label dot append. Yes. So let's encode our image. So you can now say encode labels, which equals to labels encode fit transform labels. Let's say return np dot array under images. Let's say encode underscore labels. Yeah, so labels encode. Label underscore encode. Ooh. Find the label encode. Encode. Now let me explain what I'm doing right now. So first of all, this process is to load and pre-process our image. So we said from the beginning that it should iterate over each subfolder in the given folder path. So it should like count. I should pick from each of the subfolders. So you should check the subfolders in the given folder path. So we say for each image in the subfolder, it should read the image. It should resize the image by 100 by 100 pixels. So all the images must be the same, so that it's going to help us to be able to train our model properly. So all the image size should be coincident and same. So, and it's also going to flatten it to a 1D array. So after that, it's going to append the flattened image, and the corresponding class name to the label list. So each image is the this particular code sees, and it has already resized by 100 by 100. Is going to now flatten it and then append the label to it, the label that was already there. So it has encoded the labels with label encoder. So whatever, because it's the images are in two separate folders, one for class 1, one for class 2. So it's going to convert whatever the label it is, it's going to convert it to a kind of a binary system for it to be able to understand. So once you convert it to a binary system, maybe it will say the first folder is class 1, the second folder is class 2. So it's going to append those labels to it after it has encoded the labels. So that's what it's going to do. It's going to label the class name, which class they belong to, and then it's going to encode the labels. It's going to encode the labels into numerical value, which may be 1 and 2. We assign 1 and 2 no matter the kind of name you give to the folder. So once it reads the folder, it's going to assign a class to it itself. So, and then it finally is going to return the preprocessed image, encoded labels, and the label encoder. It's going to return the images that have been preprocessed, which, because we have converted all the images that we're going to be training in those folders to 100 by 100. So for all the images to be the same size, and so that we'll be able to train our model properly. So the next thing is for us to now find a way to call the path, our image path. So we'll now say folder underscore path. Oh, sorry, folder. Folder path train Now this is where we're going to put our folder part now. So since I have my folder part now, I'll just leave it empty, kind of. I'm going to leave it empty like this, and then I'm going to move to the next one. We're going to say train image. Should train the images, train labels as well with the images, labels, label encoder, let's spell my label correct. No, so label encoder. I'm going to now say this equals to load and preprocess images. The images that were already preprocessed using the previous code. So we're going to put the folder path, folder underscore paths underscore train. We're going to close it. So now this particular code is for us to load our what do you call it, to load our images to the data set, to the system. Now we're going to load the model. Now we're going to call the model, which is our, in this case we're using random forest classifier. It's a machine learning algorithm that has the ability to classify, you know, images and numerical data as well. So we're going to say random forest classifier, random forest classifier. We're calling the classifier now. I'm going to say that it should see this small letter. So classifier fit train underscore images, and then we are going to say train underscore labels. We're going to close the brackets. So now I've called our model. So it's our model now is going to train the preprocessed images right now. So after that, we are also now going to give after the training now we want to do a testing, a practical testing. So we'll know whether this our model is working correctly or not. And by the way, this is a supervised learning method. So it's a supervised learning method that we're going to be using. So we already know the outcome. We know the input, which is our training. We've trained our system. We've labeled those data we're giving our system, and then we already know our outcome, just to see how well our model performs, and probably now use it for other models that we have not seen before. So we're going to be feeding it our test images and images that are also labeled, but we already know the outcome. So we're going to be giving the system for it to be able to predict the outcome of each of those images. So we're going to say define preprocess images put the image part, and then we're going to now say image equals to cv2 image read. We're going to open the bracket, we're going to say image underscore path. We're going to say image equals to cv2 dot resize image. We're going to put the size there, 100 by 100. By 100. We're going to close our bracket, and then we're now going to say image flat underscore flat. We'll say image that flatten. So this is the process method for, we're going to process the image that we're going to be feeding to the system. We're going to feed the system the our test image one by one for it to predict which class the particular image belongs to. So this is the pre-processing stage. So our pre-processing our test data set that we're feeding to the system now. So just the same pre-process method that we use for the training process, also going to use for the test process as well. So I say to flatten the image, flatten it, and then after that we're going to say return image flat. So now we're going to create a loop that helps us continue to test these images. So I want it to be in such a way that I'll put the first image, it predicts the outcome. I give it the second image, it predicts the outcome. I give it the third image, it predicts the outcome continuously until I'm done with what I want. So I'll know how many of the images it got correctly and how many of the images it got wrongly. So this is just the manual step. So let's create that loop. Let's create that code for that. So I'm going to use a while true, and then we're going to say image path is equals to input. Then we're going to ask the user to enter the path, to enter the path. Let's see, enter the path to the image, enter the path to the image, and then we're going to open another bracket. We're going to say or click type exit. I didn't do that well. Type exit to quit, and then I'm going to close the bracket, put this, and then put this. I'm going to close the bracket now. Yes. So we're going to say if the image paths dot lower image paths. If this particular piece of code is, if the image path doesn't tally, it should exit. So if it cannot locate the image, it should exit. So there will be a break. So let's say break. It should break. Yes. What if the image path exists now? We're going to say if not os.path dot exists as the image path underscore path print error file not found. File not found. That's if the person imputes a path that cannot be found and cannot find the path to where the images is going to say the file could not be found. Then to continue. So that to enter the image path. So if the image path doesn't tally, it should break and it should exit. And if the file cannot be found, you should ask if you want to continue, maybe you want to put the right, path. So the preprocessing of the image, we will say image flat is equals to preprocess image preprocess image score path, and now predict. Now you say prediction is equals to, you should call the machine learning model to predict mistake in the spelling again. Predict. Yes, predict. Then we say image underscore flat. We then say to get the predicted labels, the predicted class, get the class label from the label, because that's already encoded the labels, so that it will be able to understand. So it should like transform what has coded back to the normal listing for an output. So back to normal classes that were available in the folders. Like for example, now if my two classes, one I labeled it malignant, the second one benign case, I can the code will take it and encode it to probably zeros and one, class 1, class 0, and then after when it has trained the system, it's now testing, and it wants to predict which kind of image it is going to decode. It has to look at the label and output it in the initial classes that I labeled it at the beginning. So that's what we're going to do now. So we say predicted prediction. So prediction underscore class is equals to label encoder dot inverse transform prediction. After that, we are going to say to print prediction of print the predicted class. So we're going to say our predicted underscore class. We're going to close that. So now before we run this code, we'll have to we're going to be doing something because some of those libraries are not available yet. Like they're not available on my system, and probably yours too, they might not be available. So like the skitlearn, this thing might not be available, the OpenCV might not be available. So what we're going to do is we're going to install them manually. If you have it already, it's going to tell you to either update it or something, but we're going to install them manually first. So we're going to go to this terminal here to install them. This is now terminal, yes. So I'm going to say pip install OpenCV Python. Press enter. So it's going to try to install that if it's not available. So it's installing that. So we're going to wait for it to install before we now run our code and see if it's going to work. Yes. So let's wait for it to install. It's installing. Let's wait for it to install. I'm so sorry, I'm having flu, so probably it's affecting my voice. I'm very sorry about that, but I hope I'm audible enough. And if you have any question or anything you don't understand, you can drop a mail. I'll make this code available to you guys. The link will be under this particular YouTube channel, so in case you just need the code and you want to use the code, you can just get it easily. So the next one we're going to install is pip install SCI kit. Then we're going to put learn. Okay, so index is something that's laid on my PC. Learn, and then we're going to press enter. Let's see what it does with that. See, it's an unknown command. Yeah, I made a mistake in the pip install sci kit learn. Should install now. So that's, I think that's all we need to install, if I'm not mistaken. I think that's all we need to install. Hopefully that's all we need to install. We'll try to run the code and see if we actually did the right thing. Any mistake, we'll troubleshoot it as usual, because most of the time you write a code and then you encounter errors, you encounter mistakes, and then you run through the code, you go through it, and probably you're able to dictate where the error is. And sometimes it takes you a lot of time to dictate to the code, so it all depends. So now what we have created is we're using random forest, a machine learning algorithm, to train a particular data set. This one is in real time. It's not calculating the average, the performance of the model, or no. This in real time. We're going to be training and testing our images right away, and we're going to be seeing the results. And we're going to determine probably how good the application is, and how good our result is, and if it's trustworthy. So it's still installing the package and collecting the package, and then obviously it has successfully installed it. Yeah, let's now try to run our code and see what's up. Now, so we need to put in some things. We left some spaces for the input and image parts, the input to our folder parts. Yeah, I think there's a mistake here. Just noticing that this should be image. It should be image. We're going to run the code and see if I'm correct. Actually, so definition. Oh, okay. I think that's folder. I make a mistake. Let me change it to folder. So now we're going to put our code here's this. So this is our train code. So we're going to put we're going to be putting our folder location. This is what I want to train. So I have a benign case of probably breast cancer, if I'm not mistaken, and a malignant case of breast cancer as well. And this is a medical image case situation. So this is my train folder. So I just copy it and then I'll put it in this particular place. So yes, in the folder I need to put something like this so that it's going to be able to read it. So let's try to run it first and see. So it has given us a lot of errors. It's time to troubleshoot it. So let's go to line number 24 and see what is going on in line 24. So we say train image, comma, train image labels. Then we say label encoder. I will say label underscore and preprocess the image. I will say folder paths train. Everything is okay. What's the problem? What's the problem? Okay, it's a bit. So I don't know why it's giving that error, but let's rerun it again. It's probably updating some stuffs, so probably I'll wait for it to finish updating. It's a part of what's leading to our error. Okay, this okay, it's saying that this what file is this in module 24. Now tracing this, let's see. Label encoder is not defined. Did you mean label encoder? Yes, I mean that. Yeah, I use this. Arrow. Let's go back to the code again and try to troubleshoot some things. Let's go to the beginning and see what went wrong. We imported random forest, yes. We say import label encoder, yes. And then we define a load and preprocess image folder path. Okay. We say images, labels. Then we say label encoder. I think this here I was making the error. I made mistake here. It should be capital letter. Yeah. So let's try to run it again. Let's see what and what went what. Yes, I got another error again. So it's saying a name error encoder labels. So okay, let's continue our tracing. Class, yes. this folder paths. Okay, we said class paths is equal to the OS join folder path class name. If OS is this, we say class path, yes. And so we say for file name in OS list directory, class path, yes. Image path, OS file name, yes. Image CV2, image read, image path, yes. So you see encoded label, I think there's this here, which is going to label encoder feed transform labels, return NPRA images, encoder label. Okay, let's try to run this again and see what's happening. It's saying like 35. There's a problem that is in like 35. So while true, yes, while true, okay, I think should be this. Okay, let's try to run it again. Let's see if it doesn't give us error. So now our code is working fine now. So it has trained the model because I don't really have much images in the train. It's recommended that you have a lot of images to be able to get a more predictable model, like a model that will be able to predict accurately. So, but this particular, just for testing purpose, I just have little of those images, 32 each for each classes. Now the test class now. It's saying here that we should enter our test part. Our test part to the image. So this our class 1 is the benign cases. Then our class 2 is the malignant cases. So these are class 2's malignant case. So now I want to find the location of, let me open this and get the image location, copy path, copy as a path, copied, and then paste it here. So this should give us, the result of this should be malignant. So let's see what it's going to predict. Oh, there's an error. Say like 37. Okay, let's go to our code. In line 37, why true? I said you should check the image paths. If the image paths lower, yes, it should exit. Okay, it should break, yes. What is wrong with it? OS path exists. Image underscore path, yeah. Should print error. Final phone. We should continue. Okay. What's the error with this? Let me go to our. It said image paths. Image paths not defined. Okay, let's restructure this. Let's say image path, the image path. Let's try to run it again and see. So it's training those images. It's done with the training. Now it's saying we want to test. It's time to test. So let's copy the file location. As I've said, the result of this should be a malignant case, this particular image. So let's see if it predicts anything else. That means our model didn't learn properly. And if it predicts accurately, then that means our machine learning model is good to be tested anywhere. So to give us another error again, it's in line 44, there's an error with my code. Let's go back there. So in line 44, what is wrong with line 44? I said image flat preprocess. If you preprocess the image parts, okay. Let me go see the error again. It's saying that preprocessed image not defined. Not defined preprocessed image. Said image flat is equals to preprocess underscore image, then image part prediction. This predict, yes, prediction class level encoder inverse transform. So the preprocess image is not defined. Let's go back to our code. We define preprocess image. We said, okay, you use images here. You said the problem came from, if I'm not mistaken. You said it came from, yes. So let's run our code. So it says we should enter our image location. I already have the image location. Then paste it here. So as I've said, the result should be malignant case. This particular it gives us an error. Say like 50. We have an error with like 50 again. So let's go to like 50. We said it should print predicted class. Print then predicted class. I see predicted underscore class. So what's the error with it? Go back to our error. It said predicted class not defined. Define predicted class. Let me see. Print predicted class. Yes. Prediction. Let's go class equals the label. Encode inverse transform. Prediction. Okay. We said prediction is equals to predict image underscore flat. Okay. Processing age. Okay. There we see that name predicted class is not defined. Do you mean predicted class? Like a prediction class. Oh, so this will be a mistake. So we predicted class is this. Okay, let's run it again. Let's see. It's done with the training. Search Ctrl V. So it should give us a malignant. The prediction should be malignant. So let's see. It's predicted malignant. So our code is working fantastically. Yes. So this random forest machine learning model that I've created and was able to predict this particular image to be malignant. And truly it's malignant because let's go back to the folder. As I said, class 2 was malignant. You can see it's in other malignant. So and this test, this is separate folder. I didn't train this folder. It's an extra test folder I'm testing. It says let's continue testing again. Let's choose another malignant case. Let's choose benign case. Let's choose a benign case and see if our model can truly predict properly. So I'm using this random image here. Let's open it. This image should be benign. It should give us a benign case. Copy parts. Let's put it here. Benign. Wow. Our machine learning model is okay. So it can predict anything now. We've trained our model, it can predict anything actually. It can predict based on what it's trained on. So if you train it on multiple images, and you can keep putting it and it will keep predicting. Let's choose another random image. Let's choose this benign mask. Let's see if it will be able to get it correctly. Okay, I didn't copy properly. Let's copy the parts. This should still give us benign. Let's see if it will predict. Oh, it predicted wrongly in this case. Wow. So probably this is very difficult for it to predict actually, but that doesn't make it wrong. We trained it on little amount of image. For you to improve the system, you need to train it on a very vast amount of image. So an image not less than 500 to 1000 images. We just did it on just 32 images, so probably it's prone to error definitely. But in that case, because we have a lot of masks in both benign and malignant case and they look the same, to be honest, it may be difficult for the machine learning model to be able to distinguish. See this mask, for example, now it's almost the same as that, so it's very good, very difficult because the machine learning model didn't cram it and it has not seen this before. It was trained on that particular data set, so it's going to be difficult. So we need to train this particular machine model on a vast amount of data set. We trained it on only this folder, which each of them contains just 32 images and 32 images. But basically the images it was able to predict accurately. Let's pick this one for example. It should be able to predict this one accurately. Should be able to predict this one accurately. So as you all know, this should be malignant case. So we'll copy our folder parts, and then we'll put it should predict malignant case. Say it predicted malignant truly. So it was able to recognize the images properly, but the mask were difficult for it to recognize. So to improve this particular system, I need to train it on very large and vast amount of data sets, and to be able to classify and train accordingly. So let's pick another this is another benign case again. Let's copy it and let's see if it's making any error. This is a benign case. Benign case. Let me choose this one. See if it's going to be able to predict. This malignant. Let's choose a benign case situation. It's benign. See, this is a malignant case. Let's choose malignant. So for a benign case, this is a benign case. Copy spots. Let's put it here. See what's benign. Oh, it's predicted. Predicted the wrong thing this time around. I'll put it again. Let's see if it's the case. Let's put it again. It says malignant. No, it's wrong. But the system is not perfect. As I've said, we need to train it on a vast amount of data set. This is one of the errors that we're talking about. It's prone to error. So the more you train it, the better it gets. So that's it for you. So let's pick this benign case and see if it's going to be able to predict this as benign case. Let's see. Okay, this is the initial one I took before. I think it's having trouble with that. Let's pick another benign case. Ctrl V. Oh, I'm in trouble. Let's put it. This should be benign case. Oh, it's just selecting malignant. I think the system is tired. Let's refresh the system so it can give good prediction this time around. Let's rerun our code. Let's break it. Let's run it again. It's training. This is not training already. Let's put this C9. The same system that said that was malignant now says benign. The same code. So the system just needs to be trained on a vast amount of data set actually. Vast amount of data set. I can guarantee you random forest is a good classifier. It classifies properly. This code is going to be good for your projects, for trying to design something that can predict something. So it's going to be very good for you. Thank you for watching. Till another time. Don't forget, please, if you like my tutorials. Don't forget to like, to subscribe to my channel. Thank you so much. I really appreciate it.